All right, welcome back to Calc 2. Today we are going to talk about partial differentiation. Okay, so let me go ahead and share my screen with you. Work on here and let's see what we've got. All right, so first thing about notation, let me go ahead and move this so we can actually see it. All right. These little d's here, they're kind of, I don't have a name for them, they're just kind of partial differentiation d's. Okay, so they're just funky looking d's. They kind of look like twos when they're handwritten, they're not twos. Okay, but there's different ways of notation for doing this. Okay, when you need a partial derivative, we could do something like df by dx, df by dy, df right by dz. We could also put the little subscript down there. That would mean the partial derivative with respect to f. Okay, if we want to do two derivatives, x, y, that would mean partial of x, partial of y. Okay, so that's how we go ahead and do those. All right. So yeah, we talked a little bit about this yesterday with chapter 9.1, talking about we hold one of these things constants. Like when we do a derivative, we pretty much say f of x plus h y. Notice we're not changing y by a little bit of h here. We're just leaving it alone. Okay, and then dividing by h. So the idea here is we're only going to be taking a derivative of one variable at a time. Okay, so if we want to take, we'll just start with this example here. Okay, so if we have xy is 20x squared minus, now this is a good one. Okay, 20x squared minus 16xy plus 25y squared. Okay, so we have 20x squared plus 16xy, and we have 25y squared. I think I got my signs mixed up, so let's check. Minus and a plus. All right, very good. Oops. There we go. So we're going to make this a minus. I'll make this a plus. Okay. Now, if I want to take the derivative, here's my f. Okay. If I want to take the derivative of this function with respect to x, we're going to treat the x's as if they're still variables, okay? But we're going to keep y as a constant. So because we have the x down here, y is considered constant. Okay, so means we're not going to have a product rule in here. Okay, it's just we're taking the partial derivative with respect to x. So what is the partial derivative here with respect to x of 20x squared? That's going to be 40x. All right, minus. Well, the x is the variable, so it's pretty much taking the idea, like what if I had 16 pi x? I want to take that derivative. We're just going to have 16 pi here. Okay, so in this case, I want 16y x, take this derivative. Right, the 16y is considered a constant. The x is a derivative, so we're just going to have 16y here. Okay, and then 25y squared. Well, y is a constant, so all of this, as far as x is concerned, this whole term here is considered to be a constant. So we're done, right? Because the derivative of 25y squared, as far as x is concerned, that's all constant. That's going to be a 0. Okay, same idea, right? We have f y. Okay, that's going to be, well, I'm going to take my derivative of 20x squared minus 16xy plus 25y squared. Right, we're considering x to be constant, so that's going to be a 0. We have negative 16xy. Well, the y is the variable. That's what we're taking the derivative of. The 16x, that's all constant. So it's constant times the variable. Take the derivative of the variable, constant slide through. Okay, plus 50y. Okay. Oh, we didn't have a z, did we? Oh, they just wanted to evaluate it at this point. Okay, so what df by dx here is? We just want df by dx. Okay, and this was what, 20x squared minus 16xy plus 25y squared. Actually, I should do that way. So I'm going to take this with respect to x. That's going to be, again, 40x minus 16. X is a variable, so y is still constant. Okay, so the derivative of x is just going to be, right, x to the 0, x to the 1. We just have the constant left. Okay, and there's nothing left. And we want to evaluate it at, what do we want to evaluate? We want to evaluate at 1, -3. Okay, so that's going to be 40 of 1 minus 16, -3. So that's 40 plus, right? That's going to be 48. 16 times 3 is 48. Negative times negative is positive, so we end up with 88. Okay. And then the last one here is going to be Fy of 5, -3. Okay, so we want Fy of 5, -3. So derivative with respect to y of 20x squared minus 16xy plus 25y squared is equal to, x is a constant, so that's a 0. We have 16x, okay, negative plus 50y, all right? So x is 5, so we have negative 16 times 5, and then plus 50 times minus 3, so 16 times 5, I think that's negative 80, right? And then minus 150, so that should be negative 230. Okay, 513. All right, so that should be our answer for this thing. All right. So, oh, they want us to type it in. Okay, well, this is going to be 40x minus 16y. Okay, they're going to let us check it out at the same time? Or no, probably not. All right. Oh, minus. All right. Very good. All right, so this one was going to be minus 16x plus 50y. All right. And then we came up with, what, 88 for this one? And then we have negative 230 for the next. So let's see what we got. Oops, print. How about do 4? Ooh, fun. Okay. What we're going to do is we're going to find partial of x, partial of y, and then we're going to plug in some points. Okay. So here's our function. F of x, y is equal to, what did we end up with here? We ended up with negative 4e to the 6x minus 5y. 4e to the 6x minus 5y. Minus 4. Okay. Now, I tend to like these because they're just a little bit tricky, but I'm going to ask you, like, what does this mean, right? When we have a minus sign up here, or we adding a negative, what does our rules of exponents say, right? We have a to the r times a to the s, that is equal to a to the r times, or a to the r times s, or plus s rather. All right, so when the bases are the same, we add the exponents. When the base is the same, we get to add the exponents. Okay, so this could also be read as negative 4 e to the x, e to the 6x rather, times e to the negative 5y. And separating out the exponents like this might be a little bit easier for you to see things. Okay, so now it's real obvious as to which parts are derivatives and which parts aren't, rather than trying to mess with the u substitution here and trying to deal with that. Okay, so we're going to make it easy to look at and work it this way. All right, so when I want to take, well, what's the partial with respect to x? right, of negative 4 e to the 6x e to the negative 5y. So remember, we're taking the derivative with respect to x. Okay, so this is considered constant, but it's times. This is considered constant. So what we have is negative 4e to the negative 5y times the partial with respect to x of e to the 6x. All right. A lot of math is taking something that looks complicated, applying your rules of algebra to massage this thing into a problem that doesn't look hard. Okay, and there's no crime in doing that. Pattern recognition is a big part of doing this. So now that you have this, like you can take this derivative. This was something you learned in Calc 1, right? So this is negative 4e to the negative 5y times 6e to the 6x, right? We have e to the 6x times the chain of 6x, right? That's just 6. So this is going to be negative 24 e to the 6x times e to the negative 5y, okay? The whole point of this is to try to make it so that it's really easy for you to do the problem and not have to like get flustered with like, what does this mean and how am I doing it? Okay, that's fine. So if we wanted to do that, we could say these substitutions are a little hard when you have partial derivatives because you have to remember like you're taking the derivative with just x. So you could do like a u equals 6x plus 5y here, and then du like that is equal to 6. So we would have our negative 4 e to the u and then du, okay? So we'd have negative 4 e to the 6x minus 5y times du would be 6. So we'd still end up with like the same thing, okay? And either way you want to do it is just fine, okay? When you're first starting, this might be a better way to go. After you've had a little bit of practice with it, you might want to, you might want to graduate to this, but I'm not, either way you like to do it, that's how you're going to go. And sometimes, if it's a harder problem, I'm going to separate it out so I don't get confused. Okay, it's just the way that goes. So pattern recognition is powerful, and make the problem yours. Okay. We also want to evaluate it at 2, -1. Okay, so what is f(x) of 2, -1? So that's going to be negative 24 e to the 6 times 2 times e to the negative 5 times -1. Okay, so that's negative 24 e to the 12 times e to the 5. When the bases are the same, what do we do with the exponents? We add the exponents. It's negative 24 e to the 17th. Looks like a delightful number. All right. So we're going to type that in. And then what do we have to do as well? We had to do y. Okay. So what is f of y? Okay, of negative 4 e to the 6x minus 5y. Same idea. Okay, negative 4 e to the 6x times e to the negative 5y. Right? This derivative, okay, we haven't taken the derivative yet. This is going to be negative 4e to the 6x, okay, and then we want to take the derivative with respect to y of e to the negative 5y. These are all considered constants. They float through the integral sign, right? Not the integral, the differentiation. Okay, so we have to take the derivative of e to the negative 5y. That's e to the negative 5y times negative 5, because we have our chain. Okay, and then we'll put this back together and we'll say, great, that's 20 e to the 6x times e to the minus 5y, right? Now we want to evaluate this thing. 2,3, okay? So we're at 2,3. So we have 20 e to the 6 times 2, and then e to the negative 5 times 3, all right? So we have 20 e to the 12 times e to the negative 15. When the bases are the same, we add the exponents. So it's 20 e to the negative 3. All right. And that would be our solution for that. All right. So let's go ahead and have a look. See if it makes a liar out of me. So let's see. Go back up here. What did we have? We had 24 e to the x, e to the minus 5y. Okay, let's see if it takes it the way I would want to put it in. So e 24, e to the x, 6x, okay, and then e to the negative 5y. Let's see if it complains. Oops, I want this. I want negative 5y. Okay, so let's see if it yells at me. It did not like that. I should have had a negative in here, shouldn't I? Okay. No, it did like it. All right. And then we took our derivative with respect to y. What did we have here? We had 20 e to the 6x, and then we had e to the negative 5y. I'm surprised it doesn't yell at me to make that a simplified thing, but since it doesn't, it's gonna work the way we want it to. All right, now we're gonna double check here. Let's see. So this was negative 24 e to the 17th. Delightful. Okay, so this was, what was this, negative 24 e to the 17th power. All right, see about that. All right, and this was what, 20 e to the negative 3. All right, double checking a little bit here. 20 e to the negative 3. There we go. All right. All right, we'll come back to that. We may come back to that one. We'll see. We'll go back to that one. That one looks hard. Okay, so we'll try this one. All right, so we want to find the partial of x, the partial of y, partial of x at this point, the partial of y at this point. Okay, so let's see what we got. We have to write this thing down. So we have, oops, I want f of x, y to be x squared plus 4y cubed over x cubed plus y to the 4th. All right, and we want the points 3, negative 4. We also want the points 2, negative 1. All right. So this problem is going to be a pain. So when I want to take my partial with x, what I want to do is we can divide out the top. Okay, if I've got 4 quarters, I am allowed to take 1/4 plus 3/4. So think about this, right? I'm doing laundry. I got 4 quarters, like literal, coins. And I've got 1/4 in one pocket and 3/4 in the other pocket. I still have $1 on me. Okay? Not enough to do laundry, but I've got, 4 quarters. Be careful, because if a lot of people like to do something like 4/1 plus 4/3, and they want to divide out they want to separate out the denominator. Okay, I started with $1. This is saying I have $4, and then I have $1 and like 33 cents, and I can't turn my $1 into $5.33. Okay, you can't do that. Okay, even if you change these down here, like the 2 and 2, that's still $2.66. Okay, you can't do it. So the denominators, you want to change out the denominators, that's fine. But if you change out the numerators, you're going to have problems. Okay, or I should say this. I said it backwards. You want to change out and separate out the numerators, that's fine. But if you try to separate the denominators this way, like, it don't work. So be careful about that. As I said before, sorry to tell you, for the people who are taking Calc 2, like, you are now the person who is good at math in your office. There's no hiding behind it. Okay, so you're stuck. Okay, so we could certainly do this and break them apart and break the numerators apart, and that makes it look a little bit nicer. Okay, but we're still, it's a shame. If I integrated this, this would be a little bit easier to work with because, right, if I go ahead and, oh, there's not a 4 here, what am I doing? Right, if I wanted to take the integral, I could set this to be my u, right? My du is going to add up. I could set this to be my u, 3x squared. I have for 3x cubed. If I took a du, right, we'd have an x squared, but we don't have that. Okay, so I think the best we have here is a quotient rule. Okay, so then we have got that going on, right? So this one's not so bad. This one is going to be quotient rule because we have to take the derivative with respect to x. Now remember, y is going to be considered a constant. Okay, so when we take the derivative here with respect to x, we have x squared over x cubed plus y to the 4th. Okay, so remember taking quotient rule, right? That's derivative of the top, okay, times the bottom, minus the top times the derivative of the bottom. Okay, and then we also have to do it with this one. So plus derivative of the top, okay, times the bottom, minus the top times the derivative of the bottom. All right, so all I'm doing there is I'm just kind of laying out the plan, saying what do I want to take derivatives of and what am I dealing with, because quotient rule is not the funnest thing in the world. Okay, both of these are divided by the bottom, so this is going to be x cubed plus y to the 4th squared. Both of this is going to be x cubed plus y to the 4th squared. Okay, so we have to get, finish off the quotient rule here. Okay, remember, taking the derivative with respect to x. What is the derivative of x squared? Right, it's 2x times x cubed plus y to the 4th. Okay, minus. Now we have x squared. We're just going to write this down. And then the derivative of x cubed plus y to the 4th. There's a plus here. So this derivative of this part is just going to be 0. We have times 3x squared. Okay, and then the whole thing is divided by x cubed plus y to the 4th squared. Delightful. Okay, the next half of this thing, because we're only halfway there, we're taking the derivative with respect to x. What is the derivative of 4y cubed? That's 0. Okay, minus. And then we have 4y cubed, and then we need the derivative of this part. So that's going to be 3x squared. Derivative of y to the 4th, 0. Okay, and again, all divided by x cubed plus y to the 4th squared. All right. So now we're starting to get ready to put this stuff together. Okay, we have 2x to the 4th plus 2xy to the 4th minus, this is going to be 3x to the 4th, right? And this is all divided by x cubed plus y to the 4th squared. Do yourself a favor, never multiply this out unless like people specifically ask you to. Just leave it alone. Okay. Plus, and then what do we have here? We have 12 x squared y to the 3rd over x cubed plus y to the 4th squared. Right? They have common denominators still because that's how we started, right? We started back up here by just separating these things out because it was just a little bit easier to look at. Did you have to do this? No, not really. But again, if you're allowed to separate things out and take it into little pieces and put them together. So that's what we have. So combining terms, right? 2x to the 4th minus 3x to the 4th. Well, that's a minus x to the 4th here, isn't it? I have a plus a 2xy to the 4th, and then a plus 12x squared y cubed. And there's nothing else I could do with that, is there? Nope, that's a 3x, and that's just times, so 3x squared times y to the, okay, we're done. And then we have x3 plus y to the 4th squared. All right. They're making us come up with a value here for it. They sure are. This is 3, -4, right? That's what they want, is they want the value of 3, -4. Jerks. All right. So we have to plug this thing in, right? This is the x value, this is the y value. Right? So what do we have here? Right? We have -3 to the 4th plus 2 times 3 times -4 raised to the 4th power, delightful. Okay, plus 12 times 3 squared, and then -4 cubed. All divided by, Lord, who comes up with these numbers? Okay, this is 3 cubed plus -4 to the 4th, and we're going to square the whole thing when we're done. Okay, so yeah, that's a kind of a calculator issue, isn't it? So here's what we're going to do. Pop, pop. So we have -3 caret to the 4th, because the negative's on the outside. Okay, plus 2 times 3 times negatives on the inside, we're going to raise to the 4th power, so that's going to be positive numbers. So raised to the 4 caret 4. All right, 2 times 3 times 4 to the 4th. Minus, because we're going to have 3 negatives here, right? Minus 12 times 3 squared is 9 times 4 cubed. Okay, we're just going to write that down as the top. -5457. At this point, when I type in my answers, it really is going to be a fingers crossed sort of an idea here. Okay, so here we have 3 cubed, -4 raised to the 4th. That's going to be a positive number, so we're going to add 4 to the 4th power. Okay, and then we're going to square it. 80,089. Is it 59 or 89? What did I say? 89. Okay, I'm sure that's a delightful number when we take this fraction. So I'm going to go ahead and say 54, 57. I'm going to be really lazy about it. Divided by 80,089 equals, watch what you can do. You got math, hit your fraction button. It didn't like it. They're too big. So we're not going to worry about it. Okay, we could probably go through and see, wow, 5 is 4, it's 10. 10 plus 11 is 21. 8 and 8 is 16. 16 plus, now, this is not divisible by 3. This one is. But I'm not going to go through and try to find prime factorization in this so I could factor out whatever's going to factor out. We're not going to do that. So we're just going to leave it alone, and we'll go back to our piece here and see what are we doing. Oh, f of x. So we're going to type that in. All right. What are we doing? I don't want this. I want this. All right. So what was our answer for just the generic thing here? Okay. We had -x to the 4th. All right. I hate all this white space they give you. Like, do I really need all of this here? Goodness, how big this is? Tell you what, let's put this up here. We'll put this down there so I can type it all in. So we have a fraction. All right. And on the top, we have -x to the 4th plus 2xy to the 4th plus 12 x squared times y cubed. All right, and now on the bottom we have parentheses x cubed. If they don't let me do this, I'm going to be a little upset with them. Fourth and then squared. All right, let's see if they allow me to do this answer here. Partial derivative. Beautiful. There's a lot of moving parts here. All right. First things first, check your signs. No, it should have been okay. Did I write it down right? I don't think I did. This is an x squared at the top, right? No, we did. We got it right. 2x. This thing minus x squared. That's going. We have that. 0. We have 3x squared. Sorry, I'm looking. Checking this one. So did I set up my integral or my derivative correctly for the second part of this thing? We have the derivative of the first times the second plus or minus the first. I will bet I forgot to do, no, we're good here. Right there. It's negative, and I decided to be a positive. All right, let's change this. Negative. Negative. All right. Yeah, I think that's where a mistake was. Yep. So let's type this in instead. This is going to be completely wrong. All right, so we have a minus 12 instead. Let's see if we can fix this. All right. All right, that's better. Unfortunately, when you take your quizzes, they're graded by a human being. That would be me. So you make this kind of mistake, like that's not the whole problem wrong. All right, that's like a tiny, it depends on how many other mistakes you made, but that's really not what I'm going to care about too much. So try to be good about it, but you know, so be it. All right, let's try for y. Okay, let's see if we can go a little bit fancier. Okay, do a couple more, do a couple of things at the same time. So what is my original thought here? It was x squared plus 4y cubed. X squared plus 4y cubed divided by, what do we have? We have x cubed plus y to the fourth. X cubed plus y to the fourth. All right, and we want to take the derivative with respect to y. So we could take this as one thing. All right, so again, we have a quotient rule. So we want the derivative at the top. So we're going to say x squared plus 4y cubed derivative times the bottom minus the top times the derivative of the bottom. All right, and this is the derivative with respect to y over the bottom, what? The bottom squared. This is the 3. No derivative, just squared. All right. So what are we going to have here? We're going to take the derivative of this term here with respect to y. So the x squared, that's 0. That's going to be 12y to the squared, right? Times x cubed plus y to the fourth minus x squared plus 4y cubed, right? And we need the derivative of this bit, all right? So if we just take the derivative with respect to y, we've got 4y cubed, all right? And then this is all divided by the bottom, leave it alone. This is x cubed plus y to the fourth squared. So let's go ahead and FOIL this out and see what we've got. So this is 12 x cubed y squared, x cubed y to the 2, right, plus 12 y to the 6, right, when the bases are the same, we add the exponents. 2 plus 4 would be 6, minus, all right, we have 4x squared y cubed, right, that's this piece, minus, don't let me forget the minus, and we have 4 times 4 is 16, okay, y to the 6th, all divided by this delightful thing. There's some common terms here, aren't there? Okay. X3. All right, so do I have an x3 y squared? Not quite. So we're just going to break this down. All right. I also don't have an x squared y cubed. So minus 4x squared y cubed. But I have 12 minus 4, 12 minus 16 y to the 6th. So it's going to be a minus 4 y to the 6th all over x to the 3 plus y to the 4th raised to the 6th power. All right. And then we're going to plug in, what are we plugging in for this one? 2, -1. All right, to get the rest of this. So we're going to type in 2, -1. This one doesn't quite seem so bad because 1 and 2 are not terribly big numbers, but everything else was kind of a pain. So this is going to be 12, 2 cubed, -1 squared, minus 4, 2 squared, -1 cubed, minus 4, -1 to the 6th, all divided by 2 cubed plus -1 to the 4th squared. All right, so not so bad, but still not great. That's positive, right? -1 squared is positive. 2 cubed is 8. 8 times 12 is 96. Okay. Negative times negative is 1, 2, 3 negative signs here, plus another one that's going to be a plus, right? Counting up all my negatives. So here we have 4 times 2 squared is 4. 4 times 4, 16. Okay. And then negative, right? So this is to the 6th power, so this is positive, so we have a minus 4. Okay. And on the bottom here, we've got 8. 2 cubed is 8. -1 to the 4th power is plus 1 squared. Right? So let's see here. We have 96 plus 12 over 9 squared. 96 plus 12 is going to be what? 108. All right, divided by 81. So this one looks a lot nicer because I can cast out a 3. Okay, so 3 goes into 108 how many times? So 3 times, so that's going to be 9. That's 36. So we could have 36 over 27. We can keep going though, can't we? So 3 into 36, right? That goes 12 times. So we have 12. 3 into 27. That's not, we can keep going. Here, let me show you the other way. All right. So if we have 108, there we go, 108 divided by 81, all right, 4/3. So we're going to be able to say fract there, 4/3. So this is equal to 4/3. All right. So we're fine for that one. Oops, what did I want? This one I did not. No. Yeah. right here. Okay, so we're going to have a fraction. Okay, we have a 12x cubed y squared, right, minus 4x squared y, oops, oh boy, there we go, x squared y cubed minus 4y to the 6th power. Have x cubed x cubed plus 4y to the 4th. Right? What do I have a 6 sitting there for? This should just be a squared. Whatever, it's 6. Did it again. Squared. 2. All right, my fingers are crossed. We're hoping for the best here. Check the answer. Yay. All right. I screwed this one up, so I'm not going to worry about this one. Yeah, I know. Just going to get it wrong on purpose. Great. And last one, what do we get for that? We got 4/3. It's not going to like it, is it? Because it says ran to the nearest thousands. Okay, let's see. 1.53. Okay, I was happy with that. I'm sorry, I would have liked the square root there, or the 4/3. I would have liked the fraction, but yeah, what are you going to do? All right. Has this been enough? Okay, it's question 4. Let's go to question 5. Let's go to 8. Oh, second order partials. All right. So second order partials means we're going to take the derivative and then we're going to take the same, we're going to take that derivative again. Okay, so it's like the same thing as second derivatives in one variable, same idea. So it's a two-step process. All right. So what do we have? We have r is equal to 4x to the 5th. Let's see if we can do this. No, we can't, because it's going to cover it up as soon as I press that button. Let's see if we can be clever. All right, so we have r is equal to 4x to the 5th minus 5x to the 4th, y to the 5th, plus 3x to the 7th, y to the 6th. Okay, we good? Okay. All right. Let me say one thing about this, which means I should probably start another video because put the important stuff at the beginning. The second derivative, right? So we could take rxx. This means take two derivatives with respect to x. Two derivatives r, y, y. This is two derivatives with respect to y. Okay, both derivatives with y. We could have rxy and ryx. This means take the derivative of x, but then take the derivative of y. So we're going to do partial of x, and then we're going to do partial of y. This one, we're going to do partial of y, and then we're going to do partial of x. All right. they are not guaranteed to be the same. All right, RXY and YRX, or RYX and RXY, they are not guaranteed to be the same. Okay. However, even the engineering classes tend not to work with functions that do that. So your book doesn't give you any functions that they aren't the same. So for you guys, you can know that RYX is going to generally be equal to RYX, okay? This is not a rule, but as far as your class goes, you're never going to be expected to do anything different than this, okay? And unless you're taking like a higher level math class, they generally don't expose you to these things. Because when I took a 400 level physics class, we had to do a lot of partial derivatives, and they kept doing this. They kept swapping them. I was like, you're not allowed to do that. He's like, oh, for this class, we're never going to have any functions that don't do it. So even 400 level physics, they just ignored the fact that this doesn't work and just decided that it did. Okay. But you're going to, you know, you'll see, like, there's like a piecewise function thing that goes on here. Like you have to arrange it for this to happen. It's not going to happen by some random polynomial or exponential that you have. Okay. Logarithms, maybe, but they stayed away from that. Okay. So for you guys, if you just decide that they're going to be the same for this book, that's true. Okay, for most undergraduate classes, that's true. But this is not a rule. You can't depend on this at all times in every circumstance. Okay, just for most of the circumstances you're ever gonna see. All right. So there, we're good. Right? So not a rule. Okay, not always true. But for every undergraduate function that they subject you to, it's true. Okay, unless again you take one of the weirder math classes that goes into this. All right, so that's second derivatives. Okay, let's go ahead and practice one. So your dx, that is equal. Take the partial with respect to x. That's going to be 20x to the fourth. Remember, y is a constant, so that's minus 5y to the fifth, and now we're taking this derivative, so that's going to be 4x cubed, okay? Plus, is that really x to the seventh? It sure is. So this is going to be 3y to the sixth, and when we take that derivative, right, that's going to be 7x to the sixth, okay? So let's just go ahead and regroup here. So we have 20x to the fourth minus 20x cubed y to the fifth plus 3 times 7, 21x to the sixth y to the sixth. All right, that is equal to partial of r with respect to x. Okay, let's do it again. So we're going to do partial of x to that. That is equal to d squared r. That's how we write it. We took two derivatives, and then we have dx, and we write the squared on the outside, saying that this is dx by dx. Okay, that's the notation for it. If you've got y's, you have dy dx. That's just how we write it. So if it was mixed matched here, we wouldn't write the squared. We would just write the two variables. Okay, the two derivatives. So 80x cubed, right, minus, remember this is a constant, so this 3 comes down, so it's going to be minus 60x squared y to the fifth, don't touch this, okay, and then 21 times 6, that's going to be 126, I believe. This is x to the fifth, as the 6 comes down, leave y alone because it's a constant, y to the sixth. If there was a plus here, there'd be 0, but if it's times, we just multiply it through. Okay, and that is our second derivative of r with respect to x. Okay, so what do we have here? We have an 80x cubed. This will be the last one for us today. 80x cubed, all right, minus 60, okay, x squared, y to the, all right, 80x cubed minus 60 x squared, that's 60 squared, 60x squared, thank you very much, okay, y to the, no, not that y, there we go, y to the 5th, all right, plus 126 x to the 5th power, y to the 6th power. Right, and that should be, this should be good. All right, very good. Do the same thing. I knew they were going to ask. I knew they were going to ask us get all second order partial derivatives. All right. So we're going to go through, we're back to the original function here. Right, so r is equal to 4x to the 5th minus 5x to the 4th, 5y to the 5th plus 3x to the 7th, y to the 6th. All right, partial of y, so dr dy. All right, so that's going to be, oh, what's the derivative of x with respect to y? This is a constant. This is 0. Okay, so we have minus 5x to the 4th, and we take the derivative of y. That's 5y to the 4th. Okay, plus 3x to the 7th, and then the derivative here, that's going to be 6y to the 5th. All right, let's clean this up a little bit. So this is going to be negative 25, x to the 4th, y to the 4th, plus 18, x to the 7th, y to the 5th. Okay, that's how we do it. Next, d squared r dy squared. We're taking the second derivative with respect to y. So we're going to have negative 25 x to the 4th. Take the derivative here. This is going to be 4y cubed. Okay, plus 18 x to the 7th. Take the derivative, 5y to the 4th. All right. So let's see here. We have negative 100 x to the 4th y cubed. 5 times 18, that is 90, x to the 7th, y to the 4th. Okay, why they come up with numbers that are supposed to be this big, but whatever. So that is our answer for this one. Okay, so let's go ahead and scroll down a bit. So we have negative 100 x to the 4th. What do we have? Y cubed. All right. And then plus 90 y to the 7th. All right. Nope, x to the 7th. X to the 7th. Y to the 4th. And cross my fingers and hope for the best. All right. These problems are so big. All right. I knew they were going to ask. Okay. R to the xy. That means derivative of x of r. Okay, so let's take the derivative of x. All right, actually, I'm going to check something here for myself, so I'm going to pause for a moment. All right, so we were going to go ahead and find this partial derivative of r of x with y. Okay, so we've already done y. What am I doing here? All right, I want to do y. All right. Okay, so what was r of x? R of x, that was this, nope. R of x was this guy right here. Okay, so we have to remember this one, 20x to the 4th. All right. Minus 20x cubed y to the 5th. plus 21, x to the 6, y to the 6. All right. We're going to take our derivative now with respect to y. So fortunately, this term only has x's in it. So we don't really care about this term anymore, okay, because it's 0. As far as y is concerned, this term, the derivative of this is 0. Okay, so this is minus 20x cubed. Take the derivative of the y, 5y to the 4th. Plus 21x squared. Take the derivative of the y, that's 6x to the 5th. All right, so that's going to be what? 20 times 5 is 100. Okay, x cubed y to the 4th, negative. Okay, plus, and then here we have 126 x to the 6th, right? No, x squared. No, x to the 6th, we're good. X to the 6th, y to the 5th. All right, that's my second derivative for that one. Let's check. Okay, we want r of yx. So we want the derivative with respect to x of r of y. Okay, what's r of y? This was negative 25, negative 25, x to the 4th, y to the 4th, plus what do we have here? We had 18x to the 7th, 18x to the 7th, y to the 5th. All right, and we're going to take the derivative with respect to x here. So taking derivative with respect to x, it's minus 25. Take the derivative of x, it's 4x cubed, y to the 4th. Okay, plus 18. Take the derivative with respect to x, that's going to be 7x to the 6th, y to the 5th. All right, so negative 100 x cubed, y to the 4th, plus what is this? This is 70 and 56. That's 12. Okay, 126 x to the 6th, y to the 5th. We get the same thing. We sure did. Look at that. Okay, so what we're looking for is r x and r y. Are these continuous? If so, then rxy is going to equal ryx. Okay, so like I said, it's rare that you're going to be dealing with this, and it's only going to be at a point. It's not going to be like for all things. But we don't have to worry too much. So that is a check you can do. It's like, are they the same? Yeah, then you're probably okay. All right. So rxy, we're going to say this is negative 100, and nobody will know which one you did. Okay, they'll not know which order you did it in. Y to the 4th. Okay, we'll say plus 126. So I may have made the same mistake twice. Right, I'm just being consistent about making my mistakes, but chances are we're going to be okay here. All right, so well done. And the same thing. Okay, so we're going to have exactly the same thing here. All right, so I'm going to stop. Okay, I'll pick it up tomorrow, and we'll continue on. All right, so I will see you tomorrow with more of 9.2.